And well, this thing lives inside those holes, and they can be the size of a grain of rice, or mostly a grain of salt.
Oh, 네.
Now, these are solid structures, but inside all these structures is a colony of tiny little animals. Now, there are over 400 different kinds of these coral polyp animals that live on the Great Barrier Reef, but they actually only make 7 different shaped homes. You'll see different shaped homes as we go across. We've got branching coral, which looks like a staghorn. We've got bushy coral, which is a short bushy coral. We've got plate coral, like that big flat one that went underneath the boat there. Actually, that's encrusting. And then we've got a bushy coral. Big round ones, and that's kind of the coral family. Obviously there's different varieties of those, but those are essentially the shapes that they build. And you can have 400 different animals. You can have 10 of them the same, but they build 8 of them the same, but all 8 of them build different styles of homes. And it's usually the environment that depicts the way they're going to build. Now, there's another organism in this relationship to make it symbiotic. It takes 2. And so you've got the coral polyp, the translucent, clear animal that lives inside a home that is built out of calcium carbonate. So you're looking at a clear animal in a white home. So if you're looking at just the animal in its home, it would be pure white. But there's colour in all of this, lots of colour. And the colour is because the little animal, the coral polyp, it absorbs into the cell structure, deep into its body, like the blood pumping through our body. It absorbs an algae called zooxanthellae out of the water. And that algae continues to live and thrive inside that little animal. And because it's a plant, it produces photosynthesis during the daylight. And the photosynthesis makes sugars and carbohydrates way more than it needs for itself to survive. And it shares the sugars and carbohydrates with the coral polyp animal. And that animal uses those energies to build its corallite home here out of the calcium carbonate. And so that's the process where they're sharing together. The algae gets a home to live in, nice safe home, and the coral polyp, it gets a food source. Now, when the water temperatures get too hot, you get like global warming and all this sort of stuff, which is creating water temperatures too hot, what happens is the algae can't survive in those hot temperatures anymore and goes off like a cabbage being left out on a kitchen bench without it being cooled. And when it goes off like that, it becomes toxic to the polyp and it spits it out. And then all the coral becomes white again. And that's what coral bleaching is. That's what's sort of taking place up north. It's just from high temperatures. We even had it here a couple of months ago where we had some really, really low tides, even the high tides were low. And one day, for 2 days, it got so hot that the coral polyps ejected all the algae. The algae disappeared and all of it became white. 3 days later, when the tides and the temperatures got back to normal, the algae came back and all the coral got back to normal. The coral here is very, very healthy. This is healthy coral. All right. So, any questions? There should be just the white tips, but most of the coral here is like really, really live. If you see actually some coral that's just like a whole colony, which the colony is a particular shape and structure. Like even that purple one there, see? That is a coral polyps that started. It's a fairly fresh colony. There's only a few branches, which means there's only a few hundred little polyps living in that one. So if the whole colony is dead, that is likely because, it's either some sort of coral bleaching or even an animal. Those starfish, or sea stars, the crown of thorns,